Hey, Dr. Clark here as always, and in this video we're going to start chapter 10 where we learn how to do statistics when not one but both variables are quantitative. Let's get started. So here's an example. Ice cream sales over here, temperature over here. As the temperature increases, the sales increase. You can kind of see this pattern, and that's what we're looking for. Are there patterns that you can find when you have two quantitative variables? And let's just spend a second thinking about this. Temperature is a quantitative variable, and sales is a quantitative variable. Okay? Before, when we had quantitative variables, maybe you had GPA as a quantitative variable, but then the explanatory variable was, freshman, sophomore, junior, senior or something. So you had a categorical explanatory variable with a quantitative response variable. Well, now we have a quantitative explanatory variable, like maybe your height in inches. That's a quantitative variable. And your GPA is the response variable. And is there a connection between those two? All right. So in section 1, we're just looking at how do you even look at data when both variables are quantitative. And then later on in the chapter, we'll get into how to do the inference. So let's start with a simple example. Here's some data on test taking length in minutes, and then the test score from 0 to 100. So a bunch of students took a test. As they turned them in, the professor marked down, okay, it took him 30 minutes to do the test, and he got 100%. It took her 41 minutes, she got 84%, et cetera, right? Okay, so the time it took, that's a quantitative variable. And the score they got, that's a quantitative variable. So we've got two quantitative variables. The way we do that is we take this person. This is one person. One person has a time and that person has a score. Here's a person. They have a time and a score, right? So each of these pairs of numbers is actually a person. And a scatter plot is a way of graphing that. So this dot is one person. It took them 30 minutes and they got a score of 100, right? That's how we graph when both variables are quantitative. We put a dot for each observation. Okay, this person took 40 minutes and the score was 84, right? So that dot represents a person, 40 minutes, 84, etc. And now you can see, well, is there some general pattern? And it turns out if you knew, oh, this person took 50 minutes, you wouldn't necessarily know in general how high their score was, right? I mean, there's all different kinds of people. Knowing how long it took doesn't determine their score. But there does seem to be a pattern here that the longer the exam took, the lower the scores were. There's sort of a general trend. And that's what we want to know how to do. So one of the things we can do is fitting a line through some data to say, well, this is what the general trend is. And this turns out to be a really important thing to do. Because a line sort of is a model. It doesn't say, well, every single, if a person took 40 minutes, they were guaranteed to get a 92. I mean, this person got an 84 in 40 minutes. But the general trend, it sort of summarizes the trend we see in the data, okay? And some of the words we want to use, direction. Is it a positive or negative? So the direction is going down here, so that's negative. Is it linear or not? So it could be that the dots are sort of making a curve or something, and then it wouldn't be linear, but if the dots kind of just move down in a straight line, that would be linear. And then the strength. I said there's kind of a trend, but it's not super strong here. I mean, here's a person who took 60 minutes and got a 50%. This person took 60 minutes and got a 90%, right? So there's all kinds of variation. It's not 100% of a best fit or a perfect fit. So strength says how strong is the relationship. And then are there any unusual observations? If somebody was, say, here or here, that might be an unusual observation. Correlation is a quantification of the strength and direction of a linear association between two quantitative variables. So it's a number between -1 and 1 that you fit in a scatter plot and it says, oh, this scatter plot has this much of a correlation, okay? If it was a perfect line, it would either be 1 or -1 depending on if the line was going up or down with positive or negative slope, okay? if it's between -1 and 1, then that means it's not a perfect line, and the closer it is to 1, the stronger the relationship, or -1. The closer it is to 0, the weaker the relationship. So if you just plotted random points in a graph, then you'd probably get correlation of 0 or close to it. All right, and this is kind of what I was saying there. So what if you had a correlation of -0.56? Well, it would mean that the data is kind of moving down and probably somewhat strong, but not too strong. Okay, now what is a 0.56 though? So there's some general recommendations here. Between 0.7 and 1, that's pretty strong. 0.3 to 0.7 is moderate. 0.1 to 0.3 is weak, and 0 to 0.1 is basically no discernible pattern. Okay, so these are some just kind of nice guidelines for it. Okay, here's some examples. Perfect positive correlation is 1. Perfect negative correlation is -1. 0.1, this is, there's basically no pattern to these points here. 0, there's basically no pattern to these points. -0.7, so it's down, and it's a strong pattern, but it's not, you see still a variation. 0.6 is positive, it's decent, but not as strong as the 0.7 here, right? So it's a way of quantifying how strong those patterns are. Okay, so let's go back to the test data. What if we stuck in these 3 students right here? The last 3 people to finish, they turned it in after 100 minutes and they got 93, 93, 97. What would that do to the correlation? Well, before we kind of had a downward trend. Now it almost looks like an upward trend, or maybe 0 trend. Okay, so adding in some influential observations can affect the correlation of a set of data, right? It was going down, now it's sort of maybe going up even. So we call those influential. I think this one has a -0.56. This one has a -0.12. So still down, but not nearly as strong. Okay, so that's something to sort of pay attention to. So a summary, yeah, the correlation measures the strength and direction of a linear association. And there is this website here, and I can link this in the learning guide for you, is a way to test your knowledge of correlation. So let's jump over there a second, and we'll try some out. Okay, so on the applet page right here, correlation guessing game. This is kind of just a fun little app. You click this button, it makes a correlation, or it makes a scatter plot, and then you get to guess what the correlation was. Well, this looks like a -1, pretty strong. I'm going to guess -0.7. Let's see if we got it right. Ooh, -0.78. Okay, so I did pretty good. Giving myself a new data set. We'll go -0.6 for this one. Pretty close on that one. This one looks pretty weak. I'm going to guess -0.1. Oh, okay, a little stronger than I expected there. All right. Oh, we got some positive, but not too strong. Maybe 0.3 for this one. Okay, 0.35. Okay, you get the idea. So that's a little correlation guessing game. That's kind of fun. And then the last thing I want to say is there's a homework problem here from the book. It just shows there's clearly a pattern to this plot of data here. But if you did a correlation on it, it's 0.03, almost 0. So what it's saying is the correlation only measures a linear relationship. And this thing is not linear. It's a curved relationship. And correlation doesn't do a good job of measuring curved relationships. It measures linear relationships. So if it tried to draw a line through here, it's just going to kind of draw a line straight through like that. And it's going to be, not really, it's going to be basically a line with slope of 0, essentially. It's not going up, it's not going down, it's sort of doing both. So that's one thing to just to be aware of. Correlation measures a linear association. And so if you have a curved, nonlinear relationship in your data, then you're going to find the correlation isn't a good tool. The letter we use for correlation is R, and that's that quantification for the strength and direction of a linear association between two quantitative variables. All right, so hopefully that helps get you going on correlation. Use the guessing game if you want to do a little practice, and we'll see you in the next video.